Bismillahirrahmanirrahim. Assalamu alaikum students. Today's problem is about the electric potential energy. So let me write the problem, then we will discuss the solution together. So today's problem goes like this. Two protons in the nucleus of a uranium-238 atom are 6 Fermi apart. What is the potential energy associated with the electric force that acts between these two particles? So this is our today's problem. So before going to the solution, let me check the problem. Two protons in the nucleus of uranium-238 atom are 6 Fermi apart. What is the potential energy associated with the electric force that acts between these two particles, right? You know, 1 Fermi distance is 10 raised power minus 15 meter. Now we have to calculate the potential energy associated with the electric force between two protons in the nucleus of U-238 atom, which are this much distance apart. We know charge on the proton is positive, that is equal to 1e, which is 1.60 into 10 raised power minus 19 coulomb plus 1.60 into 10 raised power minus 19 coulomb, which is symbolized as letter E, small e. This is the charge on the proton. And we know proton are like charges, so there will be repulsive electric force between them. You know, like charges repel, and unlike charges attract. So two protons will repel each other due to the electrostatic force between them, right? Now, I want to first refresh your memory with regard to potential energy. Potential energy is a scalar corresponding to a force corresponding to a force, right? But this scalar, this potential energy function is only defined for conservative forces. There's a scalar corresponding to a force. You can interpret things in terms of force or the related potential energy. But this potential energy is defined only for conservative forces like gravitational force, electrostatic force. These are conservative forces. Check at your places what is a conservative force. You know it, but still refresh your memory. Gravitational force is a conservative force. Electrostatic force is a conservative force. Related to these forces, we define potential energies, right? Now, in case of gravitation, if I have 2 point masses separated by distance r, then the gravitational potential energy of these two masses, U of r, is G minus G m1 m2 by r, right? If I have two masses separated by distance r, then the potential energy due to this gravitational force stored in the system of masses is minus G m1 m2 by r. And in this expression, G is a gravitational constant. You know this is universal gravitational constant. And in this expression, it is assumed that when r tends to infinity, that means when m1, m2 are infinitely separated by infinite distance, then the potential energy in that particular configuration is assigned the value of 0. I repeat, the potential energy between two masses stored in a system of two masses when they are r distance apart is minus G m1 m2 by r, assuming that the potential energy is 0 when m1 m2 are separated by infinite distance, right? So you can see this potential energy is only negative. In gravity, gravitational potential energy is only negative because gravitational force is only attractive. Negative potential energy corresponds to attractive force, right? So since there is no repulsion in gravity, because of that, we don't have positive gravitational potential energy. Now let us move to charges. If I have 2 point charges Q1, Q2 separated by distance r, then the electric potential energy stored in this system of charges is 1 by 4 pi epsilon naught Q1, Q2 by r. Again, it is assumed that if r is infinite, then the potential energy in that configuration is assumed to be, assigned to be a value of 0, right? Now here, epsilon naught is permittivity of free space. You know that. Now here charges can be like, they can be unlike. So you have repulsion possible as well as attraction possible. So if Q1, Q2 are like charges, they can be both positive or both negative. In that case, this potential energy is positive. So this can be positive as well as negative. Negative when charges are unlike. Negative when charges are unlike, right? That means when there is attraction. When Q1 is positive, Q2 is negative, product is negative, or reverse is also possible. When charges are unlike, there is attraction, and the corresponding electrostatic potential energy is negative. Where charges are like, both positive or both negative, there is repulsion, and the potential energy corresponding to that force is positive. So here, when charges are like. So let us move to now the problem. So we have two protons. So you can see they are like charges. There is repulsion between them. Distance is given. We have to find the potential energy value for this configuration of two protons in the U-238 atom's nucleus. So let us use this expression. Now here U of R is 1 by 4 pi epsilon naught Q1 Q2 by R. Let us put the numbers. The value of 1 by 4 pi epsilon naught is 8.99 into 10 raised power 9 Newton meter square per coulomb square times Q1 is Q2, both are E, charge on the proton, which we have written is 1.60 into 10 raised power minus 19 coulomb. So it becomes here square, E square, that is 1.60 into 10 raised power minus 19 coulomb square. Let me extend this line. And we have R, which is 6 Fermi, is 6.0 into 10 raised power minus 15 meter. 1 by 4 pi epsilon naught is 8.99 into 10 raised power 9 Newton meter square per coulomb square. Then we have Q1, Q2 both equal to E. So it will become E square, which is 1.60 into 10 raised power minus 19 coulomb square. Then we have distance between the protons, which is 6 Fermi, which is 6 into 10 raised power minus 15 meter. Because I have told you 1 Fermi is this much distance and E is this much value. So let us solve this potential energy. When you solve it, it is 3.8 into 10 raised power minus 14 joule. Or if I write it in another unit, electron volt, this 2.4 into 10 raised power 5 electron volt. Let me encircle it. So this is our answer. 3.8 into 10 raised to the power minus 14 joule, or 2.4 into 10 raised to the power 5 electron volt. Remember, electron volt is a unit of energy. 1 electron volt is 1.60 into 10 raised to the power minus 19 joule. 1.60 into 10 raised to the power minus 19 joule, right? So this is the conversion relation between electron volt and joule. Now, as always, check the calculation at home. So we have solved for the potential energy associated with the electric force between two protons in the nucleus of U-238 atom, which are 6 Fermi distance apart. You can see this value of potential energy is positive. That means there is repulsion, and it is a large value. So there is a large repulsion between the two protons in this nucleus. Now, why these two protons do not fly apart? The reason is they are held by the attractive strong force that binds the nucleus together. I repeat, the protons, even when there is large potential energy, large positive potential energy, which indicates large repulsive electrostatic force between them, the protons do not fly apart because they are held together by attractive strong force that binds the nucleus together. So I hope you have enjoyed this problem. It was a nice little problem. So this is all for today. Do not forget to like, share, and subscribe my channel. Thank you. God bless you. Assalamu alaikum.